Yo, what up everybody, welcome to another video. In this video I'm gonna try to freestyle, I'm just kidding, but in this video we're gonna try to learn electrical stuff as soon as possible, you know what I'm saying? So yeah, basically I know for a fact that so far it's basically V equals AR and W equals VA, which is what I've done so far. And there's EC, which is alternate current, and the direct current, which is only flowable one way, and alternate current is flowable double ways. Is AC flowable double ways? Let's see if I can get an answer to this. Yes, okay, so which flows in one direction, just for DC. Alright, so basically, that's all I know so far. And yeah, resistance opposes flow. Of course, we know what a resistance is, right? Which is the ohm symbol. And yeah, Ohm's law is V equals IR, and I is like the current voltage, I think. So let's say, for example, let's say I is, what is I in V equals IR? Which is the Ohm's law, right? Yeah. So Ohm's law, V equals IR, electric current, sorry, I is electric current, R is resistance, I'm pretty sure. Resistance is basically the opposite of flow. What is I in V equals IR? What is in fact resistance, right? So it pretty much it's the which measures how much of a component or circuit opposes the flow of electric current, is measured in ohms, symbolized exactly. So let's just copy that done. I don't spend too much time, you know, beating around the bush on this. So let's go ahead and put that here. All right, so let's go ahead to the next one, which is AC alternate RMS, which is so there's like 3 lines, I think, but as you can see, DC is all one way, and AC is alternate, right? So apart from that, this is basically the 3 phases, right? Yeah, so pretty much this is what is this? What does this mean? Root mean square. Okay, so let's just call it. Let's go back to, where is it? RMS. Root mean square. Let's say, for example, fuck. Alright, so let's say, for example. And it's the standard of measuring and reporting alternating current, the standard of measuring and reporting alternating current and voltage, right? So let's put that here. It's 230 watts AC equals 325 volts peak, right? I think that's what this means. What does this mean? Peak voltage is... okay, just leave that there. Alright, 3-phase, so 400 LL, 200 watt, okay. Start the outdoor. So let's say, for example, I'll say keep this. Okay, so let's say, for example, 1 second. Alright, so let's say, for example, give this in, where is it? A text-based diagram that flows like this. Alright, let's see what it says. With a basic... yes. So let's see what it looks like. Okay, so voltage, current, resistance, power ohms. You know what? This might be better, to be honest. So one AC, one right. 3-phase, 230 watt LN motor star delta. I'm not too sure about this, but it's okay. So let's copy, let's grab that. Let's put this here. Let's grab that, put that there. Alright, so pretty much we have RMS alternating. RMS is a 230 watt AC, volts AC, and 325 peak. 3 phases, 440. Okay, so are these the 3 phases? Question mark. It's got the 3-phase motor system. Okay, so I'm not reading all that, but draw a X-phase diagram for this as well. Okay, so Okay. Land to neutral. Okay. Cool. Interesting. So let's say, for example, I'll drop it right below this. So for example, say 3-phase. Copy. Let's put this right here. Oh shit. So let's say like 3-phase. So this is what you see at the anyways, at those light what do you call this? The boxes, electric boxes. Alright, so day 4, wiring and circuits. So best conductivity is copper. So copper is the best for conductivity, which is costly, and aluminum, which is lighter and cheaper. More current is, of course, you need the thicker cable if it's more current. Voltage drop limit is great, less than 3%. Okay. So I'm assuming do thicker current cables have a voltage drop limit less than 3%. Okay, okay. Alright, so I'll just put that. I'm gonna just put this here. Alright, fuck. My bad. Alright, right here. I'm just gonna put this over here. So let's just say, yes, thicker current cables have a voltage drop limit of less than 3%, which is what it's trying to say. Protection, MCB, which is overload short. Interesting. And RCB, LCB. What do they stand for? I need the definition. MCB, electric. Miniature circuit breaker. Interesting. So let's grab that real quick. I'm going to grab a picture of this as well. So it's a MCD, miniature circuit breaker. So I'm assuming it's a smaller circuit breaker. Interesting. MCB, MCCB, RCB, RCCB. Interesting. So what is RCD? That's confusing, but it's alright. MCB and RCB. So RCB is a full form of a residual circuit breaker. It's like MCB, MCCB, and DC RCB is also a type of circuit breaker. It is also known as RCD. This protective device is used to measure the current flowing into and out of the connected device. In order to make the RCB electrical work, it is vital that both currents are equal. Interesting. Alright, and RCD for fault protection and MCB for overcurrent. Interesting. So we should grab that real quick. MCB for, okay, so what does RCD stand for? Residual current device. It's an electrical device, a safety device that protects people from electric shock and prevents fires by motoring and for imbalances in an electrical circuit. Right. So let's say, for example, RCD. Right, residual current device for fault protection. It's an electrical safety device that protects people from electric shocks and prevents fires by monitoring for imbalances in electrical circuits. If it detects the current is leaking, flowing, it quickly cuts. Right, okay. It's an electrical device that, okay. So let's grab that real quick. Let me just put this right here. Let's grab a simple definition as well. Alright. Alright, MCB for overcurrent. So what is MCB used for? MCB, miniature electrical safety device that automatically cuts off power to a circuit when it detects an overload or short circuit. Like a traditional fuse that must be replaced, an MCB can reset or restore power after the shows right, making it reusable. Right. So isn't this like what we use at home? Oh yeah, it is. Okay. So an MCB is what we use in houses, question mark? Okay, yeah. Used in homes. So wait, do we need MCB and RCD together? Okay, so an RCD, okay. So I guess it's just those two that we need. So let's say, for example, let's just say like, alright. Cool, I have a diagram here as well. It's pretty nice. So you see the MCB, the RCD, which is the leakage detection one. So let's grab that real quick. Go step by step. MCB versus RCD. Residual current detection. Nice. Alright, RCD, which is the residual I just call it current detection because it detects the residual current, right? Alright, switches off electricity automatically when if there is a fault, right? Interesting. ELCB. What does ELCB stand for? Leakage circuit breaker, a safety device that protects against electric shock by automatically shutting off a power device when it detects a current leak into the ground. Interesting. It's an earth, of course. Works by monitoring the amounts of current between the live and neutral wires if an imbalance occurs. Yeah, okay, so let me just get a... So of this, I'm gonna get a text-based diagram. Do the same here. MCB curves, B homeos, C motors, D transformers. Interesting. Earthing systems. I'll just put WTF because I'm not too sure. Earthing, TT supply. I'll just do WTF here as well because it's a whole lot of fluff. Domestic wiring, ring versus radial. Radial is like... Where is it? Interesting. Ring versus radial electric circuit. So this is the ring, this is the radial, right? So let's just put it in big goofy letters. Ring versus radial circuits. So what's the real difference here? That's my question. Sockets and lights. Okay, so you use ring versus radial for sockets and lights, is it? What's the difference? Ring circuit creates a loop of wiring for sockets, allowing for... I'm just gonna get simple diagram for this as well. Human electricity, okay. Interesting. It's a lot of fluff, so I'm going to grab this and drop this. I'll take that later. What's this? Ring power from the closed loop. Okay, so I need this basically. So type is ring versus radio. Power socket chain, load accumulates, needs sticker wire. Okay. Domestic wiring, ring versus radial, breaker, wire size. Must match. Interesting. Motors, DOL, start, delta, VFD, transformers. Step up, down, losses, right? Panels, main. Industrial control, contactors, laser overloads, PLC basics. Import maker, right? Okay, so it's up to here. So if I can master this part, I think I'm good. Okay, so also one-way alternating RMS, which is a... What was it again? RMS. Root mean square, exactly. So it's a root. RMS, which is root mean square. Root mean. Just call it root mean. Let's just leave one character. There we go. So root mean square. And so root mean, and yeah, that's pretty much three-phase. Okay, so copper, okay. You need copper for best conductivity, aluminium for lighter and cheaper. Yeah, so of course to get more current to get cable. Bigger cable helps maintain voltage drop of limit less than 3%. You need a circuit breaker overload short, right? So I have pictures of MCB as well, so it's pretty good. MCB curve. What are MCB curves? B, C, and D are the most common, indicate the amount of current a breaker will tolerate before it trips. Interesting. It is crucial for matching the breaker to the electrical load. MCB, like MCB curves. Alright, let me just copy that. Alright. MCB, RCD, which is residual circuit current detection. Home motors, yeah, so MCB curves, okay. Earthing systems, let's see. connects in electrical systems non-current carrying parts to the Earth's conductive safe, right? Creating a safe path for fault currents to prevent electric shocks on, right? Interesting. Copy that image. That here. What's this? Electrical consideration. Alright. TN, okay, whatever. Supply inert plus 1 rod. Right. So let's say TT. Electrical. Where is it? TT. Earth rod in earth. What's the difference between TT, TNS? What's the difference between TT, TNS, and TNCS? The TT system has the system and installation in Earth independently via separate electrodes, while TNS is just completely separate neutral and Earth conductors throughout the entire system. TNCS combines the neutral and Earth conductors in the supply network, but separates them at the point of installation. Interesting. So let me just grab this real quick. Like TT, TNS, and TNCS. This is a diagram, so it's pretty good. TT, where is it? TNS, TNCS, there we go. Perfect diagram. So let me just have the thing over here, so it's pretty good. So it's okay. Domestic wiring, again, ring versus radial, sockets and lights, breaker, wire size must match. Okay. Advanced DOL, star, delta, VFD, transformers. So these are the different types of motors, these are different types of transformers. Shut up, step up, down, losses, okay, panels, main, okay. Industrial control, contactors, relays, overloads, PLC basics. Measure, continuity. So measure is basically voltage measuring, is it? Measure does, because V equals IR, right? Does voltage measuring. From the company, Measure can measure voltage. So Measure is pretty much, the Measure applies a very high voltage to the cable and measures the leakage current. Right, okay. So is the Measure related to voltage? Yes, a Measure, also called an insulation tester, is directly linked to voltage. Because it generates high DC voltage to measure the resistance of insulation. Like a standard ohmmeter that uses low voltage, Measure applies voltage from 250 watts up to 10,000 watts or more to test the test for insulation integrity by measuring resulting low current. Right, interesting. So let's call it LEC. Continuity loop impedance. Load calculation, diversity, cable chart, short circuit calculation. Standards are these. The wire colors are live, neutral, and earth. Special systems, solar PV, it's done. Okay, so I don't really need this for now. So I'm going to get rid of the special systems part because it's confusing right now. Because we don't really need it right now. Okay, so practice map. Okay, so first week we're going to try to do this. So we know V equals IR and V equals hold on. V equals IR and W equals VA, right? So AC, we know what that is. Three-phase, almost, protection, okay. So that's pretty much up to here, right? So protection is up to here. So let's just have differentiation here. So let's say, for example, where is it? going to try protection after protection right here. So let's add some lines over here. So we separate the first week and the second week, which is domestic wiring and device sizing. So let's say, for example, domestic wiring and device sizing, which is, where the fuck is it? Domestic wiring and device sizing. And device sizing, I don't know where that is. Motors, starters. Motors plus starters, so that's to here, I guess. SLD, fault tests plus instruments. SLD, where is it? SLD, fault test. Where the fuck is fault test? Okay, it's not here. Instruments, okay, so that's part of SLD to these. Right. So it's pretty much, okay. Panels, PLC, solar. Backup systems, right? So pretty much that's what it's saying from this. The whole thing summarized. So, right. Alright, well, we can do this in 3 months, for sure. Let's get expert in 3 months. Let's quickly master this part. So we know these, right? One direction, which is like batteries and EVs. And alternating, which is homes, and 50-60, because you need to like always change back and forth. Because like batteries can flow from like in one direction, things like plus, positive, negative. How does it flow? Does current flow from positive to negative, negative to positive in batteries? Continue. Fuck. Conventional current is defined from flowing from positive to negative, right? So pretty much, so current flows from positive to negative in direct current. Okay. That was such a monkey brain question, but it's fine. So it flows from positive to negative. So I'm gonna draw a goofy thing, so then it goes in my head further. So I'm gonna go on Canva draw. I'm going to draw a goofy positive to negative thing, so it fucking sticks in my head for the rest of my life. Positive to negative. That's literally me, bro. I'm going to draw it in a way it makes sense. You know what? Because it's 6 minutes left for 30 minutes, so I'm gonna try something different. Okay. Positive. Okay. To negative. So let's say happy face to sad face. Alright? This happens when it's direct current. Okay? Also known as depression current. I'm just kidding. Because it goes from positive to negative, right? So it's depression current. Depression current lamol. Right? So it goes from positive to negative. Right? If you all want to double check this shit, like, what current flows from what current flows from negative to positive? Is there anything? Conventional current. Is that yeah, exactly, there's nothing that flows from negative to positive. But there are like a whole physics aspect of it, I'm pretty sure. Electron flow. But it's positive negative, exactly. From electron from negative to positive current is determined. So direct current is pretty much okay, so direct current flows from positive to negative. Yes. Okay, but alternate current flows from positive to negative to positive. Is that it? Okay, so the direction the flow periodically reverses, so it flows from positive to negative, and then right. Okay, so alternate current is basically the opposite of this shit. Nice. All right, so let's say elect, and I'm gonna draw like AC over here. So A, big goofy letters, which would be like AC, and then that's like this too. So AC is like legit my motivation. Goes from positive to negative and negative to positive. Alright, so we're like legit my motivation. That but hell no. See, now this shit goes in my head, you feel me? Alright. So what else is there? Alright, so we have three phase, which is star and delta. So delta is pretty much like, let's see, star versus delta. Let me see what it looks like. Where the bros at? I'm trying to bend, like I'm trying to get me a 10, like star versus delta. So what's the difference here? Line current equals phase current. Alright. What's the difference? What's the difference? The star or Y connection has end-to-end, bruh. Give me a simple one. Star connection one, this is oscillator. Is mainly required for power transmission network for longer distances, whereas delta connection mainly distribution networks and is used for, bruh, stop with all this rambling, bruh. Hold up, let me try it. Simplify it for my monkey brain, please. Alright. Y connection. Okay, so star equals gentle start, lower voltage power coil. Voltage per coil, right. But I can't just delta is full power, low voltage per coil. Interesting. I still don't get the point of this shit though. But we'll grab the screenshot. Like, it'll be like star versus delta. I'm gonna type the definition here. So it'll be like the wires, three wires meet at a single neutral point. Each wire sees less voltage. Good for starting motor slowly. Gentle start, lower power voltage per coil. Okay, so these three wires meet at a single neutral point, right? And then I have this like into like this, and then we'll be like delta, which is on a different. So let's say, for example, there is a gentle start, lower power voltage per coil. We'll do delta, which is wires form a triangle, no neutral, and then each wire says full power, and good for running motors at full power. Okay, so we'll just do this real quick. Let me grab a example as well. Star versus delta. Alright. This is pretty good. So I'll grab this one. Or I could probably star versus delta, there we go. Star versus delta. I'm gonna grab this as well. I think that's better. There we go. Star versus delta. This makes more sense eventually. Alright, domestic wiring plus device sizing. So domestic wiring, breaker wire size must match. Breaker to wire size. So we have the MCB and the RCD, right? So the residual current device, or the residual current detection as I call it, and the MCB, which is a miniature circuit breaker. So all of them have wires which have to match the size of electricity that flows, I believe. Does the wire size, so let's say for example, does the wire size need to match the electricity that flows? Yes. Oh, the wire size must be appropriately matched to the circuit breaker to prevent overheating and fire hazards. Right. Just to say. Alright. See, I can type fast as shit. Damn. Okay, so let me get a diagram of this. Why no way, bye. Terminal sizing. Bet. Okay, so the voltage needs to match the, okay. I don't exactly fully get it, but I need to get familiar with these symbols as soon as possible. Oh, so it's different? Okay. Let's grab this. I think this is better. copy image. Boom. Okay, so advanced motors, DOL, star and delta. FD, so let's say for example motors. Delta versus star. Interesting. Yeah, I mean, I have the delta versus star. Alright. So, what I'm going to do next is basically I'm going to try to, where is it? So transformers, step up, down, and losses. So step up, down, and losses. Let's see how this correlates. Electricity. Okay. Step up transformer. Oh, okay. Step down transformer. Oh, this is literally like this. The fucking. Okay. Step up and down transformer. So it's to like cater electricity to different sizes, basically, like power distribution to reduce electricity loss during power transmission to make the power safer for use. Right. So just grab that. So it's basically step up and down using what is it called? Transformers. So transformers is done to ensure that different sized places get the electricity that they need, question mark. Oh, intro different. That's kind of goofy though. That's kind of goofy. Like imagine you got like a fucking big ass what do you call it? A big like construction site right next to your house, but your house is like tiny, right? So then they gotta have like a specific transformers to just step down or step up for them or step down for you. So it's pretty goofy if you really think about it. So losses is measured, and losses are measured in CEV. Stepping voltage is electricity for locations, while stepping down increases it for long distance, low loss transmission. Stepping. So that's ChatGPT because this is rambling about shit. Let's see what you're on the right track. Let me clarify. So right. Okay, so step up, less loss. Step down, safe voltage. C heat in wires. FE. Okay. Right. Step down, less voltage, safe voltage. Right. Interesting. Alright. So, what's next? Transformers. Panels, million. Okay. Grab the panels real quick. It is define the operation of electrical power systems, often represented in single line diagram. Alright, so let me just try to get give me the single line diagram as a text-based diagram. There we go. Bro, it's just so clear, holy shit. So the SLD has these symbols. The resistance, gotta get familiar with these symbols. This feels like I'm studying day trading back in 2024. Like studying all these symbols. I'll fucking learn this in like 2 weeks max. SLD. Alright, main income power supply, incoming power supply. Busbars distribute power. Breakers protection devices, safety switching, isolated safety switching. Load the equipment and area being powered. Nice. Alright. Let's get a screenshot of this bullshit. One to three. Okay, so testing measure. So how do these correlate to each other? About this mega IR, continuity, loop impedance, multimeter clamp, sign load calculation, diversity, cable chart, short circuit calculation, standards, right? This is live neutral and earth. So it's part of this, I believe. That's part of this. Yeah, so this is not that difficult, dude. I can become an expert at this shit, trust. At least the technical side of things. After that, it's just fucking beating my ass until this works. Alright, star versus incoming power supply from transformer grid. The bus bursts power to multiple breakers. Breakers protect each line, and when they disconnect for maintenance, load balance, and trust loads are distributed evenly across phases to prevent overload. Right. Right. This we know what this is. So use a transformer to step up or down, and then it's measured in. This is electricity and this is heat, I think. CU and FE. I keep forgetting what that means. I'm gonna rewatch this video, so I'm gonna get it. CU versus FE. So CU is in electricity. And I see you again. Copper is significantly better than iron. But that's not what I'm asking. It's more reactive than copper. Interesting. But I got the different definition down there, so. Ohm's law, domestic wiring, device sizing, that's right. Alright, well. I'm CB, so we know what this means. Residual current detection miniature circuit breaker. So that's what we use at home, the miniature one. Work on motors, contactors, and so star delta zeros. Learn SLD drawing, the single line diagram, which is what I always do. I'd always draw in single line diagrams. Fault finding, test equipment, going to industrial panels, PLC basics, solar and backup systems. Cool. Alright, this was a good 40 minutes. I've been recording for 40 minutes at this point. I'm gonna rewatch this video, so I hope you guys got some entertainment out of this video as well. I'm gonna make a series out of this, try to get as good as possible, and yeah, that's pretty much it for this video, and I'll see you guys in my next one.